G'day there, you're watching the Aussie BIM Guru, and today we've reached part 2 of my Revit door family series. So in part 2, we're going to be looking at hinges. Now, before anyone gets too crazy, I know hinges, usually we wouldn't model them. I'm using this as an example to show something a little bit more detailed. For those that do want to add that detail to their doors, typically I would just schedule them as data. But I'm doing this mainly just because I did have a request from a user. So I'd like to thank Wojciech for asking me to show something a little bit more detailed about modeling doors, and he did actually mention hinge families as one of these things. So I'm going to be making a parametric hinge that can swing. So we're in the running order of 5 parts here. In the next part, we'll move on to our door leaf, but we have already set up our door frame in part 1, so definitely go check that out if you haven't already. So in the previous video, we built a parametric door frame that can achieve a few different conditions and also sizes itself based on its host wall. So now we're adding a hinge set to our door. So we're going to be building an array of a component in this case, but we're going to be building a pretty intelligent component that can adjust its angle to suit the door swing. As well as that, we're also going to have an element that's impacted on the frame width. So it's actually going to factor in a little inset that we've already allowed for in the profile of our door frame, because the hinge obviously has to fit between the end of the leaf and the frame itself. And as well as that, we're also just going to look at how we can control its visibility, because it's obviously quite a detailed element that we might not want to see in every single view. So let's get started. So I'm using Revit 2020 build 2.1. So let's get started with this. So I'm just going to jump into Revit. So this is the door frame as we left it. It has the option to go between double and single rebate. It's on my GitHub if you need a copy of it, so definitely go grab it there if you don't have a copy. And you can also change the offset away from the wall, so we can push it off the wall as well. So the door hinges are going to need to work with this system essentially. So I'm just going to start a new family, but I'm going to be working with this starter family that I built in the previous part. And I might just in this case create a new subfolder just called hinges. And I'm just going to copy this starter family into hinges. This is essentially just the stripped back generic model. I'm going to call this bg underscore dor for doors, c for component, and then just going to call this hinge type 1. So we're just building one hinge to begin with, because we're going to nest this into an array. So we're just going to begin by creating an angled component. So I'm just going to initially just switch over to doors under the category of the family. I'm also going to go to the type properties and just call this family hinge. Okay, so we need to make our family so that it swings away from our pivot point. So it's a little bit of a tricky family to set up. Now we are actually going to make this the right side of our hinge. So we're going to make this right, and this is going to be the side of our family. And we're going to make this the front of our hinge as well. So this is going to be the point where our leaf sits. So this is the face of our door leaf. Okay, so we're going to need to create a couple of reference planes just to represent the lines of the hinge. So they're going to be 1.5 millimeters each, because we made our hinge width 3 millimeters between the end of the leaf and the end of the frame previously. So we've added that extra little bit of tolerance on already. Okay, so in this case we're going to be just setting a parameter here. We might just go to a scale 1 to 1 because it's a very small component. So I'm just going to create 2 parameters here. And these are just going to be called, in this case, we'll just call it hinge thickness. So I'm going to create a new type parameter, hinge thickness, and I'm going to make this a instance-based parameter. Actually, I'll make it a type-based parameter, and I'll discuss why when we go to the array. But we're going to make this a nested family. That's ultimately the reason we're doing that. Of course, my cat starts meowing now. So we're just going to create another reference plane. I'm just going to rotate it. And this is going to be essentially the depth of my hinge. So I'm just going to associate a parameter to this and call it hinge depth. And in this case, I'll make this type-based as well. Actually, no, I'll probably make this instance-based because we may have different conditions on either side of a door. So we probably do need that to be instance-based. But the hinge zone will always be the same because I guess we're going to use the same hinge hardware. So what we're going to do now is we're going to create a hinge that sort of turns around this point here. That's going to be our hinging point. So I'm going to create a reference line, and I'm just going to draw it from here to here. Note it's not a reference plane, it's a reference line, so it has a finite constraint. I'm going to set it to not a reference, and I'm just going to align its ends to here and here, and just align it to my front plane. And all I'm doing this for is to create this little node that another reference line can snap onto. Because reference lines are quite special in how they behave. They essentially understand how to stay on a particular point of another reference line, which is really useful. So if I go and add an angle parameter between here and here, and I go and change this parameter, it moves about that point. So we can actually create a parametric rotating element around this point. Now we do need to make this angle. So this is how open our hinge is. And we're just going to call this angle, and I'll make this instance based. Okay, and we do need to make another line, in this case, offset from it by our hinge thickness. So what I'm going to do in this case is create two more small reference lines just on the ends. And I do need to parametrically constrain these based on their relationship to this point. So what I'm going to do first is I'm going to create an angle between those two reference lines, set to 90. And in this case, I'm going to lock it. Sometimes it can be quite far away for some reason. I do find angle constraints have very strange behavior sometimes. And I'll lock that one. So we've essentially created a 90-degree relationship. I also need to take an angle between here and the same reference and just constrain that to the angle as well. Finally, I'm going to take a dimension from the two reference lines and I'm going to set that to my hinge depth. And then I need to finally set the thickness of my hinge. So I'll set this to hinge thickness. So now we should have a parametric element that can rotate around that point. Now we just need to test this. So I'm just going to hide all my dimensions. And I'm just going to try adjusting that angle to something different. Let's try 35. And we can see that now we have a parametric element that essentially is going to be able to rotate around that point and be controlled by various sets of parameters. So we've basically created a pretty intelligent, flexible hinge. Now there is a condition sometimes in these families that can be quite problematic. And that can be sometimes when you go to strange angles like these, inside the family environment, it can struggle to revert back to very different parameters. So sometimes going between like an angle like that, you'll notice some of the angles go pretty strange. Sometimes if you have geometry constrained to these, it won't even let you change it to that angle. But once you take this outside the family environment to a nested family, for example, or to a project, it usually behaves quite well. So what we're going to do in this case is intentionally not really flex around too much with the geometry in here. We're going to start working with it just like it is right now. We're not going to flex it too much. But when we load this into our array, it'll be quite flexible. So I'm just going to create some geometry for my hinge. So I'm going to create an extrusion. And I'm just going to create my first hinge. So I'm going to create a little plate just between these 4 points. And I'm just going to go into front view. And I'm going to create a reference plane for the top and the bottom. So this is actually going to be the center of the hinge. So I do need to select this reference plane here and just change this to center elevation because we are going to use this to constrain our array. So I'll make this top. Cat's going crazy tonight. And I'll just set this to bottom. And this is going to be used to constrain our extrusion, which you can see here. So I'm just going to use my align tool. I'm going to go align my extrusion. And we're just going to set the height of our hinge as well. So in this case, I'm just going to add a new parameter. I'm just going to call this height. And I'm going to make this a type-based parameter because we want it to always be the same. In this case, we actually already do have a parameter called height because we're in a door template technically. So we'll just use height in this case. And I'm going to make my hinge height 100. I'll make it, 75. Just to make it a pretty good proportion. So at the moment we just have one piece of our hinge, so we do need to create the second piece. In this case I'm just going to set some properties for this piece first and start copying it. So I'm going to create a finish parameter on a type basis, because we want the finish to always be the same. And I'm going to create a new subcategory for my doors called hinges. Oh, God. Got a cat about to climb all over my laptop. Say hi to this guy, he's gone crazy tonight. He's a terror cat tonight. Anyway, I'm going to create a subcategory called hinges, and I'm just going to apply that to this hinge that I've just created. I'm then just going to copy this element just so I have all the properties I've already set up, And I'm just going to redraw the extrusions plane. So I'm going to use these reference lines instead. I'm going to constrain myself based on these reference lines. And again, I do need to go back to front view and just reconstrain the vertical aspect of those elements. And finally, I'm just going to create a little ball pivot in the middle of those. So I'm just going to create a circle. And I'm going to activate, in this case, the radius. And I'm going to set this to the hinge thickness as well. Now, to constrain a circle, it's quite easy. Most people don't realize, but when you select a circle, you can activate this little tick box called center mark visible. This creates a little crosshair that you can actually align. So you can align circles really easily. So I'm going to align firstly in this direction, and then I'm going to align in this direction. Nice and easy. I'll just make sure I actually use the right element to constrain there. Need to make sure that you use the reference planes and not the geometry. So in that case, I did actually use geometry by accident. I'm just going to go back and I'm going to reconstrain this element as well, just so it's vertically locked. And we should essentially have a parametric hinge at that point. Obviously all the dimensions and reference lines are in the way, so I'm just going to go turn off all the annotation categories. And I'm just going to use my join tool. To join, maybe I'll join in this case, maybe those two, and I might, in this case, instead actually just cut this one back. So what I'm going to do in this case is create another circle. But in this case, I'm going to trim it, delete this line, activate the center mark, constrain it. And again, I'm just going to find that reference line instead. And then just add that parametric radius as well. Make that the hinge thickness. And that way we sort of get like a little bit of a it looks more like a two-piece hinge. So it looks a little bit smarter than joining the whole thing together. Now obviously this is a really oversimplified hinge. There's probably no hinge that quite looks like this in the real world. But for now I'm just creating at least a fairly simple hinge, because once you go to more complicated types of hinges it can take a lot more work. Sometimes you might even have to build the pieces of the hinge separately, just so you can get them to sit where you want them to parametrically. But pretty much all I'm going to do at this point is I'm just going to go and save this. So I've already saved this as a hinge, so actually I'll just go Control S. I'm just going to also just go and open that original starter family. So in this case I've saved this to my desktop. I'm just actually going to copy it instead, and I'm just going to create a new component. But instead of hinge type 1, I'm going to create hinge set type 1. So I'm just going to create this new family. So this is just a generic model with all the things stripped out. And I'm going to load my hinge into my hinge set. So I'm going to make it a nested component. So we're going to create a vertical array to place our hinges. So I'm just going to place one in plan. And we can actually just test it now. We should be able to flex it quite a lot. So I can see that I can turn it around. In this case, it looks like it's gonna give me some gripes on certain angles. There does seem to be some conditions where families can really struggle. In this case, I just want to check which angle range. It seems like it's just between certain angles that can't comprehend the change. It seems okay now, but notice when I go between 225 and 135, it breaks. But then if I go to 90. Then I go 135, 125. There does seem to just be some particular angles where the family is just not happy, which is a little bit annoying. I have found that sometimes this can happen. I might just quickly open one that I built earlier just to see if this one behaves, because sometimes it can just be like one bad constraint brings the whole thing undone. So I might just instead just check this one. This is pretty much a copy of it. I will obviously put this on my GitHub, but I'll just check if this one seems happy. So it was probably just a bad constraint that was in there somewhere. If you can spot where it was, feel free to leave a comment saying that you spotted the problem. Yeah, you can see that there are some funny little conditions. Like, see that one? That's a bit weird, isn't it? So there is some funny things going on in this family. But it looks like in this case, this one should work. Okay, so we have one component. We're going to start nesting some parameters to it. So remember, some parameters were type-based, and this is because all hinges are going to adopt this property no matter what. So I'm going to go down to my hinge family, and in this case, I'm just going to take the type of hinge, and we're just going to assign some parameters to it. So I'm going to assign a finish, and I'm just going to nest another parameter called finish. I'm going to make this instance-based. I could make it type-based. I'll make it instance-based. In this case, it also has a height, so I can just call this hinge height. I don't even need to nest this if I just want it to always be 75. In this case, I'm going to create a hinge depth. So this is going to be my leaf thickness, ultimately. So I'm going to make this an instance-based parameter. So you can nest instance parameters to type parameters as long as the component isn't shared. I'm then also just going to create a parameter called hinge thickness. Cats are going crazy in the background, jeez. Okay, but I think that's all of the type parameters covered. And then there's just a few instance parameters to deal with as well. So the first one in this case is just the angle. Actually, that's the only one, just the angle of the hinge. So in this case, I'm just going to say angle. And I'm just going to make it instance-based. And at this point, we're pretty much ready to start setting up an array of hinges. So I'm going to go to my front view. And in this case, I'm just going to... Cat's going crazy in the background tonight, jeez. I'm just going to create a reference plane, and this is going to be the height of my first hinge. I'm just going to set it to not a reference. I'm then going to create another reference plane, and this is going to be the top of my hinge set. So I'm just going to create a dimension, and I'll just set this, in this case, to hinge height. I do need to change my category to doors, and then I'll just, in this case, I'll create 2040 as my height to match my leaf height. So I'll make that height. And I do need to make height an instance-based parameter in this case. So I've made this a work plane-based family. So what I can do is actually just edit the work plane of the hinge, and I'll just pick this reference plane. So that's a really good thing about work plane-based families. It's really easy to rehost them to things. If you don't make them work plane-based, it's very difficult. What I'm going to do now is just copy a reference plane and a hinge together so that this is now hosted to the new reference plane. So essentially I have a few things here. So I have my first hinge inset. So I'm going to call this, in this case, hinge inset, and I'll just make it an instance-based parameter. My second hinge is going to be offset by the hinge spacing. And this is going to be instance-based as well. And I actually need to delete this hinge, because what I'm going to do is I'm going to array this hinge up vertically. And I have a count. So in this case, I'm going to create a parameter called hinge count override, because I need to protect my array from turning into a case where the hinge is told to be 1 or 0, because if we do that, it'll break. So I'm going to protect this parameter. Anyway, what I can do now is constrain my first hinge and my second hinge to that center elevation. I can go to floor plan, and I can constrain the first. I can go to front view. I can constrain the second. And I can also constrain these to their front as well, so that when this arrays, it knows how to grow as it climbs. I'll just go to my left view so I can constrain the front of the other hinge. Okay, so now I need to set up a formula that determines how many hinges we need to place and the spacing to place them at. Now I'm going to apply this hinge inset to the top as well. So I'm going to build a formula to deal with this. So I'm going to go to my type properties, and I'm going to make a new parameter, an integer. I'm going to call this hinge count. Now this is the count that the user will input themselves. And I'll just assign this in the same area. But what I'm going to do is create a formula. So in hinge count override, I'm going to use an if formula. I'm going to say if hinge count is less than 2, then hinge count is 2. Otherwise, hinge count override is hinge count. So this means that if I ever have anything less than 2, it will just say 2 hinges. So 1 at the top, 1 at the bottom. If I say 1, or if I say 2, you can see it's still 2. If I go to 3, you can see now it's 3, 4, 5. So it just protects our hinges from ever breaking as an array. Really handy technique to use. Okay, so now we're going to actually set our hinge spacing. So the way that we need to determine this is by using our hinge count override minus our hinge with the insets taken into account. So in this case, I'm going to take my height, and I'm going to say that my hinge spacing is equal to height minus, and I'm going to put in brackets, 2 times hinge inset. And I'm then going to divide that by my hinge count override. But I need to also do -1 because we already have one hinge by default. And this should determine the spacing that I need in order to achieve the same hinge inset at the top. So we can see that now we have a parametric array that will adjust. So I can say I want 5 hinges. And I can see that my parametric array and that spacing formula make sure that I'm always working between the same range. And if my height changes, then obviously everything updates to suit as well. So we now have a parametric set of hinges that we can place on our door. I'm just going to create an invisible model line just to show someone the extent of the array. If they ever click it, they'll see the extent. This can be a really handy little tool when you have a family that you can't really see the framework behind. And in this case, now I can see that framework. The last thing I need to do is create one more parameter for, in this case, the joint width between the frame and the leaf. And this is going to be double the hinge spacing. So I'm going to call this joint width, and I'm going to make it instance based. And in this case, I'm going to say that the hinge thickness is just joint width on 2. And in this case, I just need to make sure that joint width is 3 by default. So now we can parametrically tie our original parameter in our door to the width of our hinge zone, and then all we really have to parametrically control is the number of hinges and the angle of the hinge. So I'm just going to set this back to 3 by default. I'm going to make a new type, and I'm just going to call it hinge set. But essentially now we really can just load this into our door family as a little smart component. So I'm just going to purge, that's fine, and I'm just going to save this. And now I just need to open my original door family. So if I go back to my demo folder, and I'll just open up my single swing door, I'm just going to take this and load it into my door. And if I just go into floor plan, so I can place one of these hinge sets, place on work plane. I'm just going to place it in this case at ref level. I can essentially just set up a few of those parameters, such as the finish. So when it comes to hardware and hinge finish, I have a special parameter. I might actually just use frame finish, and I'll save the hardware finish for handles. From here, we can just associate the height of the leaf to the height of the hinge set. We can then say the hinge depth is the leaf thickness. We can say, in this case, the hinge inset is just pretty much something that the user can set. Let's say by default, it's just always 150. It's just a fixed value in the door, so we don't need to assign it a parameter. And then for our joint width, in this case, we need to assign this to, I'm not sure if we have this set up to a parameter yet. I don't believe we do. So we may need to actually set this up. So at the moment, it was just in our frame, and it was called hinge gap. So let's just keep calling this hinge gap. So we'll call this hinge gap, and then we'll just make this a type parameter. And now we can associate that same parameter as well. So this way, everything's parametrically connected. So if one updates, they all update. The last thing we'll do is just add our hinge count. So we'll just nest this, and we'll call this hinge count. Now you could make this a formula where you have a max spacing of your hinges. So you could use another array to determine this. In my case, I'm just going to say that the user determines on a type basis how many hinges a door leaf needs. And I'll just put this under graphics as well. The last thing we need to change is the angle of the door leaf. So in this case, I'm just going to add a shared angle parameter. So I'm going to go down to my dimensions for doors, and I actually have a special parameter called swing angle 3D1. And I'm just going to use that as an instance basis. We're going to use this parameter to control the openness of our door leaf as well. So it's all going to be connected ultimately. Now I need to copy a reference plane in this case. So I'm going to copy this in by the frame width, and then I'm going to copy one back by the joint width, because we are going to constrain to this face. I'm going to set these both to be not a reference. And I'm going to have to firstly set this to frame width. So I have that frame width parameter that we set up before. And then I also have, in this case, the hinge gap. Now I can align my array to here and align it back to here. And now we should have a parametric hinge set. So it's on the other side of our door leaf in this case. And there it is. So in this case, I can say that my hinge angle is 0. And there we go. We can see that we have a parametric hinge set. And we can obviously open that as well. So we can say that the 3D angle is 225. And now I can see that our hinges are opening. So we're going to be placing a door leaf on this hinge set essentially. So we're going to end up with a pretty intelligent family ultimately. We'll just set it to 0 by default, and we might just move this parameter under graphics as well. But there we go. We can see that, it's starting to shape up. You could even make it instance based if you wanted to, so that we can change it on a door by door basis, just to demonstrate how the family works. So let's just save and load this back into our project now. And now if I go around to the other side of my door, I can say I have 4 hinges, and we can see that they're slightly more spaced out. Maybe I have 5. So you can see it's really easy to manipulate the family, and then I can just really quickly change the angle. Now we probably don't want to see the hinges in floor plan. They're probably a little bit too detailed. So what I can do is just go back to my door, and I can just select my hinge set, and just go to this visibility graphic overrides edit button with the hinge set selected. And I can say in floor plan, I don't want to see them. And when I'm in left view and right view, I don't want to see them either, because I'm going to be looking side on. You could also make it so you only see them when you're in fine detail level. This can be okay when you have really fine detail elements. I find it's not a good tool to use to hide entire families, but just more detailed aspects of families. So now I can actually just reload this in. And now if I go to course, you'll see that I don't see my hinges. If I go to fine, I see my hinges. If I go to floor plan, I see my frame, but I don't see my hinge. So you can control the visibility graphics as well of these more detailed elements to increase your model performance and just to make your model easier to look at in certain types of views. So there we go. So that you're quite detailed, but I guess, showing the potential of what you can do with a little bit of time. So hopefully you found that useful. These families will be available again on GitHub so that you can keep continuing on with the series, because we're going to be moving on to the door leaf in the next part. So thanks for watching this one. Again, it was probably quite complex and a little bit long, so I appreciate if you stuck it out, and I hope that you're getting a lot out of this series. If you have any comments, feel free to leave them down below. I'd like to hear your thoughts on what else you might like to see about doors as well, because I know there's a lot of things you can do with them. And if you're not already following and subscribing, feel free to do so. I make videos 2 times a week and aim to do so for as long as I can. And I look forward to seeing you in the next video. Thanks. Take care. Bye.